We're now going to convert between logarithmic and exponential form. That's the first step in really understanding logarithmic functions. A couple hints here. The base of the logarithm is going to equal the base of the exponent. So bases are always equal. Base of log is going to become the base of the exponent. And then a logarithm is always equal to the exponent. So I kind of remember these e equal starts with e, exponent starts with e. The logarithm is always going to be equal to the exponent. So let's jump right to example 1. We want to change each logarithmic statement into an equivalent statement involving an exponent. So all this involves is understanding the definition of a logarithm. So first let's practice reading this. In part A, we have log base 3 of 1/9 equals -2. So our base is 3, and our argument, the thing we're taking log of is the argument, it's 1/9. So up here we said the base of the log is going to equal the base of the exponent. So I've got a base of 3 here. So then when I write my equivalent exponential statement, the base is going to be 3. Remember, the logarithm is always equal to the exponent. So you know this -2 is going to be the exponent on that base. And then you set that equal to the argument of 1/9. So if you notice, you've got a base, an argument, and then a number over on the other side of the equal sign. All three of those have to go in a certain place. They're all going to go somewhere in the equivalent form. So base of log, base of exponent. Log's always equal to the exponent, so that's the exponent you're going to put on the base of 3, and that's going to equal the argument 1/9. And we can see that that is in fact true. 3 to the -2 power is in fact 1/9. All right, let's look at part B. We have natural log of x equals 46. So remember, natural log means log base e of x. And you don't have to write that step out when you guys are doing homework or on a quiz or a test, but it's not a bad idea to remind yourself here in the notes, and even on a quiz or a test, you can certainly write that down if you'd like. So we have a base of e, our argument is x, and the logarithm is set equal to 46. So we know this 46 is going to be the exponent on the base of e. So then my equivalent form is going to be a base of e to the 46th power equal to x. So in this case, we had a variable, this equation, we didn't know what x, like in part A, we had an expression here. We know that that's true. Here we have a variable. So if we were solving this equation for x, converting from logarithmic to exponential form would allow us to isolate the variable. And that's one of the reasons why we're solving or studying these logarithmic functions. So I'd like you guys to try on your own part C and D. And I'm going to jump to example 2 now. So here we want to change each exponential statement into an equivalent statement involving a logarithm. So now we're going from exponential back to logarithmic form. So again, remember the same things up here. Base of the log is equal to the base of the exponent, and the logarithm is going to equal the exponent. Okay, so in part A, I'm going to take a log with a base of 4, because again, my base of my exponent here is 4, so I know the base of my logarithm is going to be 4. Now, if you want to leave a space for the argument and put an equal sign, remember your logarithm is always going to equal the exponent. So I'm going to set this equal to 2, and then I just fill in my argument of 16. So base of log equals base of exponent. The log is always going to be set equal to the exponent. A logarithm is an exponent. And then we fill the argument in here. Okay, let's look at part B. So part B, we have a base of e. So we have e to the 3.4 power equals h. So if I have a base of e, I know I can use that natural log. So if I wanted to write log base e first here, just in your notes to remind yourself. So we've got log base e. So base of my log is base of the exponent. And then my log is always going to be equal to my exponent, 3.4. And then I fill in my argument h. And make sure when you guys write these that you put the base as a subscript. You don't want to write it in line with the log. Make sure it is a subscript there. And then if we know that we write log base e as natural log, h equals 3.4. So eventually you can go right to this natural log step. But when you're first practicing this, it's not a bad idea to write this as log base e. And again, I'd like you guys to practice C and D on your own, please.